Hey there! In this video, we'll talk about the domain services of the ABP framework. In a domain-driven design solution, the core business logic is generally implemented in aggregates and domain services. Creating a domain service is especially needed when you implement a core domain logic that depends on some services, some repositories for example, or other external services, or the logic that you need to implement is related to more than one aggregate or entity, so it does not properly fit in any of the aggregates. The domain services are simple stateless classes. You do not have to derive from any service or interface. The ABP framework provides some useful base classes and conventions. You could either derive a domain service from the domain service base class, or directly implement the iDomain service interface. Once you do that, the ABP framework automatically registers the class to the dependency injection system with a transient lifetime. And you can also directly use some common services as base properties without the need to manually inject them. For example, the iLogger and the iGood generator, and we'll see that in the practical part. Please keep in mind that it is suggested to name a domain service with a manager or service suffix. We typically use the manager suffix as used in the example before. Now let us take a quick look at an example from the documentation on how to implement the domain logic of assigning an issue to a user. We've created a domain service class with the name issue manager. The suffix right here is manager, and we derived the domain service class. We've injected the iRepository of type issue and good. Then we've created a method to assign an issue to a user. We've used the count async method from the iRepository to get the current issue count from the ID of the user. And as you can see right here in the domain layer, we can implement core business validations. So if the current issue count that we've got from the assigned user ID is greater than or equals to 3, then we'll throw an exception. Other than that, we can assign the issue to the user. And of course, we are getting the assigned user ID from the issue aggregate root. And also, setting the assigned user ID internally ensures that it cannot be directly set in the upper layers and forces us to always use the issue manager in order to assign an issue to a user. And as you can see right here, we've got an application service class, an example about it, and it derives the application service and an interface. We've injected the iRepository as usual, and we've also injected the issue manager. And only by using the issue manager, we were able to assign an issue to a user from an upper layer. Other than that, it cannot directly assign an issue to a user. So what is the difference between the application services and the domain services? They both implement business rules, right? However, application services implement the use cases of the application, the user interactions in a typical web application, same as we've seen in the to-do web application video. Getting the list of the to-do items, inserting into the list, and deleting, right? That's the application services. The domain services, however, implement the core and use case independent domain logic. The to-do item list should not have 10 to-do items, for example. The application services get and return data transfer objects or DTOs, while the domain service methods typically get and return the domain objects, which are the entities in the value objects. And last but not least, the domain services are typically used by the application services or other domain services, while the application services are used by the presentation layer or the client applications. And finally, the lifetime of domain services is transient, and they are automatically registered to the dependency injection system. Now, as you might remember from the entities video, we've created the customer aggregate root. It had the ID, the name, the surname, the customer group ID that we have not created yet, the navigation property of the contact information, which was an entity itself, and our value object, the address. And as you might remember as well, the customer group was an aggregate root itself. We said that we do not reference the aggregate roots by the navigation property, but rather the ID. And so in this video, we'll create the customer group aggregate root and we will set the relationship between the customer group aggregate root and the customer aggregate root. The foreign key that we've added right here will be the primary key right here. Let's see it in action. As you can see right here, this is our customer aggregate root. Here is the name, the surname, and here is our customer group ID. This is the navigation property of the contact information, and this is our value object. We've created the customer group class right here, and it derives the aggregate root of type good, and it's got two properties, the code and the description, and they are both string. We made them nullable only to get around the error that we get in the unit tests because of the nullable property that we've missed right here. And here is our empty constructor and our internal constructor with these two methods, setCode and setDescription. As we've done with the other classes, we've created some classes right here in the domain shared project, and you can see our validation right here. We've got max code length and max description length, which are right here. And these two methods will set the code and the description for us with a bit of validation, whether it was null, and with the max length validation that we've created in the customer group cost class. We've also added the entity framework core mappings. Let's take a look at them. As you can see right here, the customer group aggregate root has a many with one relationship with the customer aggregate root, because of course each customer group has many customers. And the foreign key of the customer aggregate root is the customer group ID. As you remember, the contact information that we've got right here is an entity, not an aggregate root, so we were able to use the navigation property right here. But as for aggregate roots, we have said that it must be referenced to by the good, not the navigation property. And next up is the customer manager class, which is the domain service, our lesson in this video. And it's got a few methods right here that apply actual core business logic. We first injected the repositories as usual, one with the type customer and the good, and the other one is with the type customer group and good. And after injecting them, we've got our first method. The first method is create customer group async of type customer group. So it creates a customer group, a new one. It'll pass in two parameters, a code string and a description string. It'll use the repository of the customer group to see if the code that you have inserted, because if we take a look right here, we've got a code and a description, right? So it'll see the code that you have passed right here, if it already exists or not. And as long as this variable is not null, then it actually exists. So it will throw in this user-friendly exception, the customer group with the code number is already registered. Otherwise, it'll create a new instance and use its constructor right here, and it's going to use the GUI generator. As you can see right here, we did not inject the GUI generator because we are using the domain service. So we can use services from outside without injecting them, like the GUI generator or the iLogger. So we've generated the GUI, we've inserted the code that we've passed from here, and same with the description. And it returns the customer group object. The second method is change customer group code async. It changes the code of an existing customer group. So it passes in two parameters, a customer group object and a string with the name new code. The new code that you want to update instead of the existing customer group code. So we've made a variable right here and we use the customer group repository, the first or default async, to check if the new code is the same as the existing code. And so if this returns null to the variable, then that means that we have a new code. It's not the same code. And so it passes this check. It's no problem. And if the ID of this variable is the same ID of the customer group that you've inserted right here, then it also passes. Otherwise, it will assign this code to a whole other customer group. And so if these two checks did not pass, then it'll throw this user-friendly exception. Customer group with the new code is already registered. And so if they pass from here, then we'll use the customer group object to set the code with this method, and we'll pass in the new code. The next method, as it says, set customer group async, It will set a customer to a specific group. It'll pass in two parameters, two of type object, the customer object, and the customer group object. It'll use the iRepository to count through the customer repository. It'll see if the ID of the customer group that we've inserted is the same as the customer group ID that we're looking for. And if that's okay, if that checks, it'll also check whether the ID of the customer already exists in this customer group or not. If the ID of the customer is new and the ID of the customer group that we've inserted exists, then we can go on to our core logic. If the customer group count is greater than or equals to 10, then we'll throw in this user-friendly exception. No more than 10 customers can be connected to the customer group with the customer group code. Otherwise, if it's less than 10, then we can set the ID of the customer group to the customer group ID of the customer that we've inserted. And the last method in our manager is set customer group async of the generic type customer group. It'll take in two parameters, the customer object and a string of customer group code. You see right here again, the code of the customer group. This is the code that we will be inserting right here. We'll use the customer group repository to find the customer group by the code that we've inserted. If we take a look right here, the iRepository that we've injected is of the generic type customer group and good. And so the customer group code that we've queried right here exists, then simply we will grab it by the code and pass it in to the customer group variable right here. And then we'll pass both the customer group variable and the customer object to the method that we've made right here, the set customer group async. And of course, if we did not find it by the code, then we'll throw in this user-friendly exception. Customer group with the customer group code was not found. Now, before jumping to the unit tests that we've created right here, we want to take a look at the seeder so we can understand more before we dive in. We've got the data seed contributor class that we've used in the previous videos. We've got our injections right here, and we've got a new method, create customer groups. This method, as its peer in prior create customers method, will both be called and seed the data every time we run our unit tests. So we're using the customer manager to create customer group async for group A with the description of group A, group B with the description of group B, and group C with the description of group C. If we take a look right here, it's these two parameters, the code and the description. Then we're using the customer group repository to insert group 1, group 2, and group 3. And right here we've got a for loop that iterates from 1 to 10. We've created a customer object right here and we filled in all of the parameters, generated the good, added the first name as the number of the iteration and the last name as well. So the good, the first name and the last name, the constructor of the customer. After that, we've used the customer manager to use its method, the set customer group async, that takes in the customer object and the customer group. So the customer object is going to be each one of those 10, and the group is going to be group 1, which is group A. We'll do that 10 times, we will fill group A 10 times. And after that, we've used the customer repository to use its method, the insert async method, to insert the customer object and toggle the autosave. And I guess you know where this is going. We want to check whether our core logic is working or not. We want to see if it's going to throw this exception or not. Let's also not forget the DB sets, the DB set of the customer groups in the interface and in the class, because I forgot to mention that. And now we can jump in onto the tests. As for the first test, create a valid customer group code. We've created a customer group instance and we made sure that it was null. We've used the unit of work so we do not get an exception, and we've used the customer manager to use its method create a customer group async that takes these two parameters. The description is default, so just need the code, which is group D. The seeder has already got A, B, and C, and this is group D. After that, we use the customer group repository to insert the customer group. And now we're checking if it's not null. And it should be not null. And we'll see when we test it. And on the second test, when we try to add an existing customer group code, it must throw an exception. So we're using the throws async user-friendly exception. and we're using the unit of work so it does not return an exception. And we're using the customer manager to use its method, the create customer group async with the type string group A. As you can see right here, if the code is the same, then it should throw the user-friendly exception. It already exists, it's already registered. The seeder's already got group A, and so this should pass as well. As for the next test, the change the customer group code, we've created yet another null customer group instance, and with using the unit of work, then we grab the record of this object using the customer group repository first or default async method, and then we've used the customer manager to change the customer group code async, which is this method. And we've passed in the object as a parameter along with the string of the new code. As you can see right here, we've got the customer group object and the new code. So we're taking a look at the new code and we're checking with the customer group repository using the first or default async method to check and see whether this code exists or not. The code is group D and the ones that we have seeded are only A, B, and C. So it does not exist, and since it does not exist, it will return null right here. And as long as it is not null, and as long as the ID of it is not the same as the ID of the customer group object itself, then it shall pass this one and not throw the error. And we shall use the setCode method, which is defined in the class itself. And then if we get back to the test, we're going to use the update async method from the customer group repository, and the code of the customer group object should be group D, and we'll see if it passes. And as for the next test, which is set customer to a group, we've created yet another null customer object, and with the unit of work, we have grabbed the record of the first or default customer that does not have a customer group ID, where the customer group is null. I think if we take a look at the seeder right here, we've got some customers that do not have a group. So it'll bring the first or default one, it'll grab the record of the first or default one, and then it'll pass it to the customer object. After that, it'll use the customer manager to use the set customer group async method, and it will pass the object and a string of group B. Let's take a look at it. It is this method of the generic type customer group, and it'll take the customer object and a customer group code string. It'll check the string that we've passed, the group B, and it'll see by the first or default async method coming from the I repository, the customer group repository, and it does exist, right? Because when we seeded the data right here, we've got group B, right? And that will be passed to the customer group variable. If it was null, it'll throw this exception, and it is not null because we do have group B. And then it'll call the prior method, the set customer group async, with both the customer object and the customer group. And after passing the customer object and customer group object as parameters, it'll use the customer repository to count through and see if the customer group ID exists or not. And yes, group B exists, so this one shall pass. But the customer ID does not exist with it at the same time, because if we check right here, in the seeder, it is one of these three, and each of them does not have a customer group ID. And so this condition actually passes. After that, it'll go through this if statement, and the group B doesn't actually have 10. The only one that actually has 10 counts is group A. And so it's not going to throw this error, and so the ID of the customer group will be set to the customer group ID of our customer object. So one of these three will have group B alongside. And after that, we're going to use the customer repository to use its method, the update async, with the customer object. And so the customer group ID of the customer object that was null right here should not be null, and we will check once we run the test. On the next test, cannot set customer to a group with more than 10 customers. We did the same thing that we did right here. We've grabbed a first or default record of a customer that does not have a customer group ID, and then we assigned it to group A. Let's check the method again. Same thing is going to happen. The string is group A, it'll pass here, and then we're going to call the prior method with both the customer object and the customer group, which is group A. And after calling the method, the customer group ID, which is group A, will match right here, but the customer will not match, and that will pass to the customer group count. And after that, we are coming to our core logic. And like we said before, group 1, which is group A right here, does already have 10 customers, and so it will throw this exception, the user-friendly exception. No more than 10 customers can be connected to the customer group with the customer group code. And if we look back right here, after using the customer repository and updating the database, it should throw a user-friendly exception, and we'll see if it passes or not. And now let us run the unit tests. And they're all passing. Please make sure to take a look at the documentation. This has been the Domain Services. Thank you for watching and see you next time.